Welcome! In this video, I'm going to be going through the calculator steps that will allow you to do single variable hypothesis tests on your graphing calculator. I'm going to focus on the z-test, the t-test, and also a percentage test, which is a one proportional z-test. And I will do this through this application that you see here on the screen. This is the graphing calculator X84. It's very similar to the Texas Instruments TI-84 calculator, and you will need to unlock the pro features on this app to do what I'm about to do. But I do have videos on my YouTube channel that will actually do these problems more in depth, but they will do so from a teaching point of view. This is a supplemental video that will just show you how to get the data into the calculator and to get the outputs that you need to solve the problems on your homework or just go along with the notes that I've provided. The three examples are actually three of the examples I've already lectured over in class or I have put online. But first, let's prepare our calculators. So whether you have the phone app or the physical calculator, follow these steps to prepare your work. Now, the first thing you should do is clear a blank screen. Now, you'll notice that I have a blank screen here. There's nothing on it. And you can just hit clear and that would have gotten rid of it. If you have old equations or expressions typed in, just hit clear and that'll get this to a nice blank screen. Now, the second thing you should do is you should push the Y equal button to check for any formulas. So I'm going to push this Y equals button and I see there are no formulas here. But a lot of times in previous classes, you might have, maybe something typed into one of these. We don't want any of these linear or other functions causing confusion when we try to graph things. So make sure you hit clear to get rid of all of these. Now, if you have the physical calculator, you will see up above a plot 1, plot 2, plot 3. Make sure those are not highlighted. Now, the next thing you should do is to make sure that you don't have any plots, and in this calculator app, you would have to hit the second button and then the Y equals button, and you're just going to make sure that everything is off for your list 1 or just make sure all of these are off, okay? Just make sure they're off, and that way you can scroll down to make sure that all of these are turned off. Just make sure they're all off because we don't want, scatter plots, line graphs, or anything like that to confuse us as we plot these points. And more importantly, if these were on, then they might actually look for data that isn't actually there on the calculator or the app that you're using. Okay, now to get out of this screen, and this is very important for calc or phone users, make sure you hit the second, then the mode key. Second mode accesses this little quit, and we're going to be doing that to get back to the blank screen. So now, I will say, if you have the phone app, you may want to clear any pictures. Now, if you push the graph button, you shouldn't see anything here. But if there's something here, you'll have to clear that manually. So by accessing this close button at the bottom of the screen, I can then hit the second button, then the clear button, and now it says clear draw. There's a clear draw function on your calculator as well, but the calculator automatically, or the physical calculator, automatically clears the drawings every time you do them. Okay, the last thing you're going to do is push the stat button and also push the edit button right there and look for anything in list 1. Now you'll see I have some sample data here in list 1. I want to clear that out because we're going to be entering some data later on in this video and I don't want this data to be here. So make sure that with your arrow keys, you move up to the very top where it says L1. Your L1 is highlighted, then hit clear. Now you'll notice that all the data is gone, but your cursor is actually still up there in list 1. So push the down arrow key once, and now you're back ready to type in data. Sometimes people try to type in data all the way up here in list 1. That has its functions and its purpose, but not for us right now. So make sure you push your arrow down so you're inside of one of those cells. It's similar to a Microsoft spreadsheet here. So the next thing I'm going to do is actually run some examples. So let's hit second mode to quit out of this and get back to a blank screen. You can even hit clear to make all that go away. Okay, so as you can see, this example about Jeffrey as an 8-year-old who who established a mean time of 16.43 seconds for swimming his 25-yard freestyle, had a standard deviation of 0.8 seconds. His dad, Frank, thought that Jeff could swim the 28-yard freestyle faster using some goggles. So Frank bought Jeff some new pair of expensive goggles and then timed 35 of his swims. Now, for all of those 35 swims, his average time was faster, actually, 16:15. So Frank thought the goggles helped Jeff swim faster than that original time. Let's conduct a hypothesis test using an alpha of 5% and assume the swim times for the 25-yard freestyle are normal. Okay, so from the problem above, we have our mu and our standard deviation. We could get that because that was the population data from all of his previous swims. Then we have his sample and the sample size, which is what we're going to compare the mu and x bar against. Now, if these are statistically significantly different, then we can reject the null hypothesis. And here's our null and here's our alternative. The 16.43 is what we are testing, and this is what Frank, or Jeff's dad, thought was going to happen. It was going to be less than that. Now, if you want a more in-depth explanation to where I got all of these 6 values, again, I did make a video on this problem and taught through these parts. But let's actually skip down a little bit and do the iPhone work here. So what I'm going to do is push stat, and Android users, you can do this too, but you'll realize that things are going to look different in just a moment. So everybody push stat, and then everybody go to tests. Now, the type of test we want is the z-test, and it's a one-sample z-test. Everything we do today is going to be one sample. So I push that, and now Android users, you might be a little confused because you don't see the screen that looks like this. Although, if you're using the physical X84 or the iPhone, you'll notice that it looks very similar to this. Well, in this situation, we have to choose now between data and statistics. Now, in this problem, I didn't give you all 35 pieces of data. So what I'm going to do is I'm going to choose the stats. And this is actually what I identified in the problem. My mu naught, or the mu that we're testing, is 16.43. And again, Android users, you're not out of luck. You're just going to have to wait a little bit for me. And then I can hit the enter key or just the down arrow. The standard deviation was 0.8. All right, and now I'm going to move on to my X bar. Again, Android users, just be a little patient here. We'll get to you. The 16.15 is the X bar, and the sample size of that group was 35. Now, what's important here is this next row. This next row says mu is either not equal to the null hypothesis, less than the null hypothesis, or greater than the null hypothesis. So what you need to do is let this match the inequality of your alternative hypothesis. And our alternative hypothesis was less than. So we're going to make sure that we bop that and make sure it turns color there. And we bop that so it's less than. And one of the parts that I need done for my class is to have the graph drawn. So we're going to try the draw, and we're going to not see anything. Although, if you're a detective, you might notice that there is a slightly discolored line in the middle of this graph. Now, if you have a physical calculator, of course, you see the graph, because the physical calculator zooms in correctly onto that normal curve. But the app doesn't. So what you have to do, and this is very important, and this is true for the Android or the iPhone, is you have to stretch out. So take your fingers and stretch, because you'll notice that, that we're getting closer and closer, and wow, check it out. We're now starting to see the normal curve, okay? And we're gonna get this down to a good spot here, all right? And again, you can kind of like stretch it to taste. And there it is. This is the picture of your left tail test. See the shaded region right there? Now, another thing you need that's going to help you with this problem is you're going to need to get the values. More importantly, you're going to get your z-test score, and you're going to get your p-value to compare to your alpha. So we're going to close this here, and you'll notice that after we close it, we now see our z-value, and we now see our p-value. So our z-value is -2 standard deviations below the norm, and our p-value is only 1.9%. So since our p is less than our alpha, we're going to reject the null hypothesis. Now, if you're an Android user, you probably got a little jealous that all of those commands were inside of a menu. And I'd agree, that is kind of nice to see. But here's what the Android user is going to see. And a little note to everybody else who's at this stage of the game, please hit second mode to quit to a clear screen. Now check out this top line. Android users, that's what you would have to type in. You can see that the first thing after the z-test is the mu naught. That's our mu. It's nice that the calculator gives you this little list here. Then after the mu naught, or the mu, is our standard deviation. Then our x bar, then our n. So far we've typed in 16.43, 0.8, 16.15, 35, all separated by commas, no need for spaces. But here's the big tricky part, and you'll see me now highlighting this on this worksheet here. Your alt is the one you have to actually look at the problem at your alternative hypothesis. Your alternative hypothesis is less than mu naught, or back up here, it was less than 16.43. So according to this guide, if you have a less than, you use -1. That's why there's a -1 right there. Then afterwards, you have to put a (1). The (1) turns the draw on. So when you go hit graph, Android users, you will see this. It won't automatically go to the picture, but once you go graph, you can hit close and take a look at this formula and get your values like that. So this is how you would do this for the Android. The Android, after you go stat tests z-test, you're going to have to type in each of these numbers. And don't forget to put a (1) at the end to turn on the draw function. You'll note too that it will let you do another comma and something called color number. So if I wanted to, let's say I pick 9 and I hit graph, you notice it changes the color. That's just for fun, but I'm not gonna, you can maybe experiment with that a little bit. And if you're gonna compare one graph versus another, you can change the two colors to do so. Now for everybody using a phone app, make sure you hit second mode and then second clear so you can clear the draw. That way when you hit graph, there's nothing there. And you're ready for the next of the 3 problems I'm going to do here. So let me scroll down a little bit to show you that on your worksheet here, you still have second mode to quit and second clear to clear your pictures on the iPhone and Android. Let's do the next problem, which happens to be problem number 3. I chose problems 1 and 3 because these are some of the more basic examples of the Z and the T variety. And let's actually take a look at this problem. So some statistics students are curious if my test was a bad test. So they're claiming that my stat test was 65. Well, what I did is then I said, well, I'm going to be contrary to you, so I'm going to think the test scores are higher. So what I'm going to do is I'm going to take a sample. I took 10 students and I have the raw data here, and I'm going to perform a hypothesis test with a 5% alpha. So let's assume normal distribution so we don't have to run any outlier checks on this t-test. And it's a t-test because I didn't give you the standard deviation. I don't have the entire population's data in this example, or I didn't give you the entire population's standard deviation that I probably could have calculated from all of those tests in all of my classes. So the first thing we're going to have to do on any calculator is enter the data. So no matter what calculator you have, you're first going to push the stat button, then you're going to choose the edit. And then after you choose the edit menu, bop the edit on the phone, or just hit enter on your physical graphing calculator. And now just type in your data. you'll see that again, my cursor is below the list 1, so I'm ready to start typing. So I'll do so and hit enter after each number. And oh no, I hit the wrong series of numbers. That is definitely not the right answer. So I just hit clear and I can just redo any mistake I make. At this stage of the class, you've probably used list 1 before. So I don't think there's going to be any big trouble. But again, I might be moving a little fast because my students will have been using data in list 1 since chapter 2. But again, if you have any other questions in class, please let me know. Okay, so I have my 10 data points listed here. And what's more important is I'm going to go through each one again. I would hate to have you lose test points because you just mistyped a number. So it's always good to scroll through your data and see if you made any mistakes. And so far, I think this is pretty good. So let's now move on to what the iPhone and the physical calculator people are going to do. Well, we're going to hit stat, and we're also going to go back to tests, and this is going to be the one sample t-test. And I want to give an example here of where you have the raw data. There are examples where you will be given the statistics in the problem, but let's actually go and do the raw data here. So you'll notice it says t-test and data. Now, Android users, you don't actually see this. So you're just going to have to wait a little bit. So the mu naught is something I have to give because that's actually not in the data. And that was what my students came up with and said that is what we think the average is, or the mu is. Now, the list is defaulted to list 1, which is where we typed our data. Now, if there's nothing there, you can push second 1, and then you can see that the L1 is there. And I will show you if you hit second 5, now it says L5. Please don't change that, but in case you needed to type that in, there's your L1. Android users, you will have to type in second 1 later on in this video, so please be patient here and, again, be ready to do some of that work. Do not change the frequency, and you do not want to change the frequency because we're not going to adjust any of the values in list 1. Now, what was the alternative hypothesis in this problem? You can see that not equal to is highlighted, but we want greater than. This was the alternative hypothesis inequality, and if I hit draw, there's the picture of it. You can see the shaded of this right tail test right there, and that's going to be useful to you when you do your work in the class. But more importantly, you need your t-score and you need your p-score. So if I just close this, you can now see the t and the p. Now, if you have the physical calculator, your t and p values will be given to you on the same screen as the draw screen. So you can always kind of get the information there. So what's nice is that this actually shows you that my class average, or that sample average, was 67 instead of 65. My sample standard deviation was 3.19 or 3.2 rounded. And again, there's my sample size of the sample. So this is really nice, but what are my Android users going to do? Because they didn't get that nice menu. Well, if I go second mode, that's what my Android users have to type in. So let me show you, Android users. I'm going to back all the way up to the 65 and hit delete a bunch of times. So there it is. It says t-test, and above it, you can kind of see that it's obscured by the line above it. It says mu naught. So we're going to type in 65 and hit a comma. Then the list is the next thing I see. And you can see that this is actually going to follow what I have on this worksheet here. So the list 1 is where I type my data. So you'll hit second and 1. And the next thing I need is the frequency. So I'm going to put comma 1. Again, the frequency is always 1. Don't change the frequency. And then the alternative hypothesis in this case was greater than. So using the key here on the worksheet, the greater than symbol is the alternative of 1. Put another comma. And then finally, we need a 1 at the end to let my graphing calculator app know that I want to draw this. Now, if I hit enter, I won't see the drawing. In fact, I'll just see the data I need to write down for the problem. I would need to hit graph to see the picture. And again, kind of nice for the Android users, If you wanted to change the color, you could even add at the very end of it, like let's say comma 5, and you'd have a different color for the problem. And you can have some fun changing that number there if you wanted to, you know, comma, I don't think I hit enter. There we go. Now it shows a different color. Sorry about that. You got to hit enter after each of these changes. Okay, so that is the second example here. Let me close this off. Now remember, the screen isn't clear yet. So if I go back to graph, it's still going to be there. The physical calculator always wipes it clean like an Etch-a-Sketch, where our app doesn't do that automatically. Is that a feature or a bug? I think you can argue both ways. Let's hit second mode to get to this screen. We can clear this screen and then hit second clear, and now we're going to clear the draw. And now if I go to graph, it's no longer there. You'll notice I didn't have to pinch in and pinch out. It remembered where the previous pinch was and kept the focus on that spot. Warning though, if you do turn off the app and turn the app back on again, it may not remember your window settings. So you may have to pinch out the next time you try the problem or use it. So the third and final example here is going to be problem 5 in my notes. And this is where we're going to do a one prop z-test. So getting to a clear screen, June here believes that 50% of first-time brides have older grooms. And then she's going to run a hypothesis test to see if this is true. Now, she did a 100-person survey and 53 replied that they are younger than the grooms. So this is a one prop z-test. There was no standard deviation given, and there was actually no average given. So she ran the data and got an X of 53 out of 100. So this is what she found. And so now we're going to use the one prop z-test feature on the calculator. So if you have an iPhone or a normal calculator, you're just going to push the stat button and then push the test button, and then you're going to choose one prop z-test. Now this is where the Android users, it's not going to look like this. So that's a little bit of a bummer. Now the first thing we're going to type in is our P0. This is our assumption. Then we're going to type in our X and our N. Now our X has to be a test number value. This is not a percentage. So this would be 53 and the N would be out of 100. What's important to note is that you do need your X and your N based on the story problem there. And if you're having trouble finding that, please watch the videos that I've sent out to my class or I have on my YouTube page. Now, what was the alternative hypothesis? Now, in this case, it did match at not equal to, but in case if your other p-values or other inequalities are selected, make sure you are on not equal to. All right, then, now we're going to hit draw, and we're going to see this two-tailed test. And it's two-tailed because it's a not equal to as our alternative hypothesis. And you can copy down this picture if you'd like, or close it to see the actual values. Here we have a z-score of 0.6, a p-score that's really high at 0.5485 or 55%, which means that we are not going to reject the null hypothesis because our p-value was greater than alpha. And if you need to, again, understand the analysis of z and p and anything that we did to either reject or not reject the null hypothesis, I've made videos on those. The main purpose of this video is to show you how to do this on the calculator. So Android users, I think you're pretty much ready for the next step here, but you're also ready to know that, yeah, you didn't get to see that beautiful menu on the screen. So what you did see though, is you saw this, one prop z-test with these values. So if I hit second enter and hit delete a bunch of times, I can just kind of like model what how you would type all this in. The first thing you would type in is your P0, which is your 0.5. You can type in 0.50, but it would then collapse it to 0.5 when it did the calculations. So 0.50 is kind of stylistic, the way, a way you could do it. Now, typing in your X is the number of people in your survey who matched the success, which was having an older groom. And then the N is next out of 100. You don't need any spaces here between these commas. And then after the 100, you need to have your alt. Now your alt here, since it's not equal to, will be 0. So just use your worksheet here to refer back to what alt you need to use. It's either a 0 for not equal to, it's a -1 for less than, and it's a 1 for greater than. Again, on the worksheet you see there. Then what we need is we need a (1), and we need the (1) because we need to have it drawn. And again, if you wanted to put comma any number, you can maybe get a different color on the screen. After you hit enter, the Android will show you this screen, and then you hit graph to see the graph. And that's it. Through this almost 30-minute video, you got a taste and a walkthrough of how to use the calculator functions to get the answers that you need. We will be using this technology because we want to run more analysis of our work here. We want to basically get the higher level thinking here to what is being done for these one variable ZT and one proportion Z tests. And very soon we're going to be doing 2 variable 1Z and 2 variable or 2 prop Z tests. Well, thank you for watching, and I hope this helped you with the graphing calculator X84 app by Inception Mobile or your physical calculator. Thanks again for watching.